Good morning, everybody. Today we shall continue the chapter Is Matter Around Us Pure? So, in previous class, we shall discuss about the importance of colloidal solution, properties of colloidal solution, suspension, properties of suspension, Tyndall effect, saturated solution, unsaturated solution, how saturated solutions are prepared, and concentration of solution. Okay, dear students, today we shall discuss about the separating the components of mixture. Here, separating the components of mixture means it is a heterogeneous mixture can be separated by simple method like hand picking, sieving and filtration, etc. So note down here, it can be separated by simple method like hand picking, sieving and filtration method are used, and it can be separated the mixture. Sometimes special techniques are used to separate the components of mixtures. Sometimes special techniques are used to separate the components of mixtures like evaporation, centrifugation, decantation are using a separating funnel, sublimation, centrifugation, chromatography, distillation and fractional distillation. So these are all the methods are used to separate the components of a mixture. So let us see one by one. Evaporation. Here evaporations means it is a method used for separating a volatile component. It is a method used for separating a volatile component or solvent from a non-volatile component or solute by heating the mixture. So evaporation method is used for separating a volatile component in a solvent from a non-volatile component in a solute by heating the mixture. For example, ink. You know that all of you know that the ink. So ink is a mixture of a dye and water. Ink is a mixture of dye and water. Here dye means multicolors, many colors. So it is called it as an dye. So ink is a mixture of many colors. And so ink is a mixture of dye and water. If some ink is heated in a dish, the water evaporates and the dye is left in the dish. So note down the point here. If some ink is heated in a dish, the water evaporates and the dye is left in the dish. Similarly, we can separate a mixture of salt and water or sugar and water by evaporation method. So, and then centrifugation method. So very important method. So carefully observe here and note down the points. So it is very important in your examination also. So this machine is a centrifugation machine. So observe the figure. See, this is a centrifugation machine. So the method of separating denser particles and lighter particles from a mixture by using the centrifugation machine. So it is called it as centrifugation. The method of separating denser particles and lighter particles from a mixture by using centrifugation machine. So it is called it as centrifugation. For example, if we take some milk in a centrifugation machine and spin it rapidly or rotate rapidly. So if we take some milk in a centrifugation machine and rotate it rapidly, the cream separated from the milk because the cream is less dense than the milk. Because the cream is less dense than the milk. So here the process of separating of components of a mixture. So now it is you have to see about that. The centrifugation methods are used. So if we take some milk in a centrifugation machine and spin it rapidly, the cream separates from the milk because cream is less dense than the milk. So that method is the centrifugation methods. So we are not separating through the filtration, so we separate through the centrifugation. Here centrifugation method are used and it can be easily separated by the small particles. So here the filtration will not through the filtration the particles are not separated, so we use the centrifugation method and easily to the particles are separated. And then decantation using separating funnel. So this figure is very important in your examination. So how can we separate a mixture of two immiscible liquids? So here let us see about that. So let us try to separate the kerosene oil from water using a separate funnel. So this method is used for separating a mixture of immiscible liquids. So liquids separate into different layers depending on their densities. First, to separate the kerosene oil from water using a separate funnel. Pour the mixture of a kerosene oil and water in a separating funnel. So it forms separate layers of oil and water. The water can be separated by opening the stop clock. After the water flows out, the stop clock can be closed. When you close the stop clock of the separating funnel as the oil reaches the stop clock. And to repeat the mixture of oil and water in the extraction of iron from its ore. The lighter slag is removed from the top by this method to leave the molten iron at the bottom in the furnace. So the principle is that immiscible liquids separated out in layers depending upon the densities. And then sublimation. You know that in your previous topic. So what do you mean by sublimation? So once again repeat it. So here sublimation method is used to separate the mixture. Here the method is used to separate a mixture of a sublimable component from a non-sublimable component by heating the mixture. The method is used to separate a mixture of sublimable component from a non-sublimable component by heating the mixture. You know that the meaning of the sublimation. So here, what do you mean by sublimation? You know that in your previous class. Here sublimation means a change of state directly from solid to gas without changing into liquid state is called sublimation. So how get it separate? So let us see. So for example, if a mixture of ammonium chloride and common salt is heated, the ammonium chloride sublimes and can be cooled and solidified and collected and salt is left behind. If a mixture of ammonium chloride and common salt is heated, the ammonium chloride sublimates and can be cooled and solidified and collected and salt is left behind. And then chromatography. So here chromatography, the process of separating of components of a mixture is known as chromatography. So in the Greek word chromo means color. So this technique was first used for separation of colors. So the name was given chromatography. So chromatography is the technique used for separation of those solutes that dissolves in the same solvent. Here the method is used for separating colored components from a liquid by using a filter paper or blotting paper. Here in Greek word here chromo means color, and the technique was first for separation of color used the technique was first used for separation of colors, so the name was given chromatography. So here for when the mixture is separated, so let us see through the activity. So put a drop of ink near one end of a strip of filter paper. Put a drop of ink near one end of a strip of filter paper and dip the end of the paper in a test tube containing water. So dip the end of the paper in a test tube containing water. So ink is a mixture of two or more colored components. You know that ink is a mixture of two or more colored components. The technique which is more soluble in water rises faster and get separated. With the advancement in technology, newer techniques of chromatography have been developed. So you will study about chromatography in higher classes. So it is used to separate the colors in a dye, pigments from natural colors, drugs from bloods also. And then distillation. So here distillation means the method used for separating a mixture of miscible liquids by boiling the mixture and cooling, condensing the vapors. Very important. Say, observe here and note down the point. Here the fractional distillation. Here distillation means the method is used for separating a mixture of miscible liquids, means mixed liquids, two or more liquids. It can be used for separating a mixture of miscible liquids by boiling the mixture and cooling and condensing the vapors. So let us see how the mixtures are separated through the distillation. Here distillation is used for separating a mixture of two miscible liquids having sufficient difference in their boiling points. It is used for separating a mixture of two miscible liquids having sufficient difference in their boiling points. For example, if a mixture of acetone and water is heated in a distillation apparatus, the acetone, which has a lower boiling point than water, first boils and cools and condenses and is separated from the water. Mixture of acetone and water is heated in a distillation flask and distillation apparatus. The acetone, which has a lower boiling point than water, first boil and cools and condenses and is separated from the water. So very important figure. So you will practice in your practice in your home. And then fractional distillation. So this is also very important in your examination. So here the question is arise. Draw a neat label diagram of fractional distillation. Here fractional distillation is used for separating a mixture of two or more miscible liquids whose difference is boiling point is less than the 25 Kelvin. Fractional distillation is used for separating a mixture of two or more miscible liquids whose difference in boiling point is less than the 25 Kelvin. So the apparatus used for fractional distillation is similar to that used for simple distillation, except that a fractionating column is fitted between the distillation flask and condenser. The fractionating column has glass beads which increases the surface for the vapors to cool and condense. So fractional distillation is used for separating the components of petroleum and separating the different gases from air. So note down the point here. Fractional distillation is used for separating the components of petroleum and separating the different gases from air. And then separation of components of air. So you know that air is a mixture of gases. Air is a mixture of gases. The components of air can be separated by fractional distillation. The components of air can be separated by fractional distillation. So air is so observe this diagram. So air is compressed by increasing the pressure and cooled by decreasing the temperature to get liquid air. So here air is compressed by increasing the pressure and cooled by decreasing the temperature to get liquid air. The liquid air is then allowed to warm up slowly in a fractional distillation column. The liquid air is then allowed to warm up slowly in a fractional distillation column. Then the different components separated at different heights depending on their different boiling points. Here the air is compressed and cooled and by increasing pressure and decreasing the temperatures you get the liquid air, and liquid air allowed to warm up slowly in fractional distillation column we get gases separated at different heights. So here the boiling point of oxygen and argon and nitrogen. Here the boiling point of water, oxygen in Celsius is 183, argon is 186 Celsius and nitrogen is 196 Celsius. And then purification of solids by crystallization. So purification of solids by crystallization. So crystallization is the process by obtaining a pure solid in the form of crystals from its solution. So crystallization is the process obtaining a pure solid in the form of crystals from its solution. Observe the figure. Here the pure copper sulfate crystals and impure copper sulfate. So crystallization is the process of obtaining a pure solid in the form of crystal from its solution. For example, by crystallization we can obtain pure copper sulfate from its solution. So let us know through the experiment. So dissolve about 5 gram of copper sulfate in minimum amount of water. Dissolve about 5 gram of copper sulfate in minimum amount of water. Filter the solution to remove the impurities. Filter the solution to remove the impurities. So evaporate the solution in a china dish and to get a saturated solution. Evaporated the solution in a china dish to get a saturated solution, and cover the solution with a filter paper and allow it to cool. So pure copper sulfate crystals are formed. Dissolve 5 gram of copper sulfate in a minimum amount of water and filter the solution to remove the impurities, and then evaporate the solution in a china dish to get a saturated solution, and cover the solution with a filter paper and allow it to cool, and pure copper sulfate crystals are formed. And then types of pure substances. So pure substances are two types. You know that there are elements and compounds. So elements are the basic form of water which cannot be broken into simpler substance by chemical reactions. So elements are of three types. They are metals, non-metals and metallites. When you see the periodic table, you have to see that the three states of matter, solid, liquid and gas. In solid, you have to see that they are metals, in liquid non-metals, and solid liquid are metallites. So properties of metals. So the metals have luster. They are malleable and ductile. They are good conductors of heat and electricity. And they are sonorous, and they are make sound. So metals are luster are shiny. They are malleable and ductile. They are good conductor of heat and electricity, and they are sonorous to make a sound. For example, iron, aluminium, zinc, mercury, copper, silver, gold are the examples of metals. And properties of non-metals. So non-metals do not have luster or shine. Non-metals do not have shine or luster. They are non-malleable or ductile. They are not malleable or ductile. They are pure conductors of heat and electricity. They are pure conductors of heat and electricity. They are not sonorous. They are not make sound. So they are not sonorous. For example, hydrogen, oxygen, nitrogen, iodine, carbon, sulfur, phosphorus are the examples of non-metals. And then properties of metallites. So metallites are elements which show some properties of metals and some properties of non-metals. So metallites are the elements or show some properties of metals and some properties of non-metals, or it takes the both the characteristics of the metals and non-metals are called metallites. Or metallites means shows the both, it takes the both the characteristics of the metals and non-metals, it is called it as metallites. For example, boron, silicon, germanium are the examples of metallites. And then compound. A compound is a substance composed of two or more elements chemically combined together in a fixed ratio. A compound is a substance composed of two or more elements chemically combined together in a fixed proportions. That's why it is called it as compound. For example, water, carbon dioxide, sugar, salt, iron sulfide are the examples of compound. So let us see the differences between the mixtures and compound. Mixture. It is composed of two or more elements or compounds mixed together. So in compounds, it is composed of two or more elements chemically combined together. The composition of the components in any ratio. In compound, the composition of the components in a fixed ratio. So in a compound, the composition of a component is a fixed ratio. But in mixture, the composition of the component in any ratio. In mixture, it shows the properties of the components. It shows the properties of the components. In compounds, it shows the different properties than the components. It shows different properties than the components. And mixture, the components can be separated by physical method. The components can be separated by physical method, but in compound, the components can be separated only by chemical method. Okay, dear students, today we shall discuss about the importance of separation of different components. So here the evaporation, centrifugation, decantation, sublimation, chromatography, distillation, fractional distillation and separation of components of air, purification of solids by crystallization, types of pure substances, and then compound differences between mixtures and compounds. Okay, thank you.